Hi, my name is Naomi and this is my AE 1601 glider report video. Presenting to you the flying squirrel. For this assignment, we were given the goal of creating a glider from scratch that could successfully meet the standards and requirements provided utilizing the information we have accumulated about how we analyze an aircraft's flight properties. The approach that I took for this assignment was to first take notes on what was being required and the qualitative and quantitative aspects that would be useful towards constructing a working glider. Some of the aspects were about the glider's overall design and others were about the coefficient of lift and drag. For the vehicle requirements, I considered that the vehicle construction had to be 16 by 16 inches. It had to be a minimum flight distance of 20 feet, and it was supposed to be built by balsa wood, although this wasn't a strict requirement, and it needed to remain intact during flight and be hand thrown and have nothing motorized. And the measures of success kind of overlap with these requirements because the lift overcoming the weight consistently for at least 20 feet is pretty much the same as the minimum flight distance of 20 feet. The same thing applies to the gliders staying intact. For the requirements of the report, I mentioned that the need is to locate the center of gravity and relative to the quarter chord, estimate and explain the estimation of the lift and drag coefficients, and highlight the primary trade-offs and alternatives. And in terms of measures of success, these also somewhat overlap. The trade-offs and alternatives should ultimately lead you to a design that meets the requirement of 20 feet, which draws back to the vehicle requirements. So you can see how some of these requirements overlap. These requirements would be needed later for following a successful build. For the alternative designs, the wings specifically, I considered the rectangular, the trapezoidal, and the tapered wing. And for the trapezoidal wing, it was pretty much a loss because the trapezoidal was mostly advantageous for high-speed designs, and the rectangular had some good aspects, but the tapered wing was better. For the alternative designs for the wing placement, we see that there are a lot of great characteristics or pros for the above the fuselage placement of the wings, and so much for the other two. There were some advantages, but not a lot, and more so cons. So we're moving on to the alternative designs for the dihedral, and I saw a lot of advantages for the polyhedral, which is the design further to the right, but it was a difficult build, and for this glider project, it was more so just a minimum success, so I wasn't looking to make things too complicated. For my best design alternative, I chose the placement of the wing above the fuselage, the simple dihedral, and the tapered wing. And this is because in combination, these help me with the lift as well as reducing the induced drag and just creating an overall balanced center of gravity for my glider. For the sizing of my vehicle, it wasn't too complicated of a process. I mostly took into account the wingspan, which I wanted to make less than 16 inches, the aspect ratio, which was going to affect the lift of my glider, the fuselage, which was also going to affect the lift in terms of weight, which I just made about 75% of the wingspan, and the ratio of the tail area to the wing area. And in terms of the initial design choices, I made a iteration 1, which was basically just following those sizing criterion, and I have the dimensions here, and I used cardboard just for a testing material. And this was the flight. So for testing this design, I noticed that there was a lot of instability and there was some turning motion, and the tail was too heavy. And so overall, the CG was a bit far back and it didn't travel the required distance, and it was not the right material. In terms of my design iterations, I made 4 iterations, and each one was just trying to improve upon my last results and trying to reach the required 20 feet and also some stability. And I initially made some changes to the tail size and reduced it for my first iteration, and my planned design changes had to do with the center of gravity, decrease in tail size, and so on. And my final design ended up being pretty similar to my fourth iteration, which was the closest and most successful to my requirements and reached 20 feet. For this design, I ended up getting a CG that was behind the quarter cord, and my estimated coefficient of lift and drag were found using a tool that helped me to get my coefficient of lift and drag equations, and you can see the graphs. And this is my best video. This one reached 40 feet. My design iterations ultimately helped me to get a very successful build, and I felt that the more time I spent on improving on each iteration, it just overall made the final design very successful in terms of the wings, the tail, and the fuselage. Ultimately, my design did meet the requirements. The way I could improve my design is by using a different dihedral, because I did see that the polyhedral had some more advantages than the one I used. This project has really taught me a lot about how to make an aerodynamic aircraft and just the properties of making a glider. And here are my references. Some are information, and I also include for images and the tool I used.